Welcome back to a new session. We start calculus. It's a very important topic for you. A lot of marks from calculus. So let us start learning. This is part 1. We discuss the concept of limit. The starting point for understanding calculus begins with the concept of a limit. Consider the equation y equal to x minus 4. Usually, we substitute values for x and we get the corresponding values of y. Look at the table below. We have x values and corresponding y values. Look at the specific number 5. When the x values approach closer and closer to 5, 4,999, 4,9999 like that, we are approaching the number 5. Now, the y value approaches closer and closer to 1. Same thing from the right. If you look at the table, you can see starting from 5.2, when x approaches closer and closer to the specific number 5, the y values approach to 1. The number 1 is referred to as the limit of the equation as x approaches 5, and this is actually the basic idea of limit. We state this as limit of x minus 4 as x approaches 5 equal to 1. Or we can read it as limit of x minus 4 as x approaches 5 equal to 1. Another way, limit of x minus 4 as x tends to 5 equal to 1. So if fx equal to x minus 4, we have limit of x minus 4 and x approaches 5. We substitute 5 for x. So we get 5 minus 4 equal to 1. Let us now look at the graph of fx equal to x square plus 1. We notice that if you approach 2, the x value 2 from the left, that is 1,67, 1,77, etc., the number x coordinate, all the x coordinates approaching the number 2, then the corresponding y coordinates starting from 3.8, etc., approaching 5. So from the left, x approaches 2, y approaches 5. Also, on the other side, if you start approaching 2 from the right, that is 2,36, 2,28, 2,21, etc., approaching 2, x coordinates approaching 2, then the corresponding y coordinates approaching the number 5. So we read that. You can see x values approach 2, y values approach 5. Then 5 is the limit of the function as x approaches 2. Now, limit of fx, that is limit of x square plus 1. We substitute x equal to 2 and then we get 2 square plus 1 equal to 4. That's how we calculate the limits. Here we have few popular identities which will help us to answer the questions on limits. You are already familiar with all these identities. Now let us come to the questions. Determine the following limits. Question number A. Limit of x square minus 1 over x minus 1, where x approaches 1. What happens here? If we substitute 1 for x, the denominator is going to be 0. Also the numerator will be 0. And then division by 0 is undefined. So what we have to do is, when the denominator is becoming 0, you factorize the numerator. Avoid getting 0 there. So we factorize, we get x plus 1 times x minus 1 over x minus 1. X minus 1 and x minus 1 can be now cancelled. We get x plus 1, and we substitute x equal to 1 there. We get the final answer 2. Another question, x cube minus 8 over x minus 2. Gain 0 in the denominator if you substitute 2. Factorize carefully. You must remember these identities. And factorize, we cancel x minus 2 and x minus 2. We get x squared plus 2x plus 4. Substitute carefully and use your calculator for the final answer. Here is the limit of the function equal to 12. Question number C. Limit x squared plus 3x plus 2 over 2 plus x. X approaches minus 2. Factorize. Simplify the x plus 2 and 2 plus x. We get x plus 1. Substitute carefully. And final answer is minus 1. Look at this question. Limit of 10. X approaches 3. What is limit of 10? That is fx equal to 10 or y equal to 10. Now the answer is 10. What is that? Look at the graph. The line y equal to 10 is a horizontal line, horizontal to the x-axis. Wherever we go along this line y equal to 10, the y coordinate will be always 10. That's why we say that equation of that line is y equal to 10. Any x value, you can start from left or start from right. Wherever you go, you can substitute any value for x, but the y coordinate, y value will still remain 10. That's why we get limit of 10 equal to 10. Look at the next question. 4x square minus 9 over 2x plus 3. X approaches negative 3 over 2. Again, we have to factorize, otherwise the values in the numerator and in the denominator will be 0. So we factorize very carefully. We cancel 2x plus 3 and 2x plus 3. We get 2x minus 3. And then we substitute carefully and use the calculator. We get the final answer minus 6. Question number F. X cube minus 27 over 3 minus x. Okay, let us factorize. Then denominator, look at the denominator. It was 3 minus x. But we want x minus 3. So we keep a minus sign outside the bracket and changing it into minus of x minus 3 so that we can cancel x minus 3 and x minus 3. Now the minus is there. So we get minus of x square plus 3x plus 9. Substituting carefully, we get the answer minus 27. Limit of 2x over x square plus x approaches 0. Imagine 0 for x. We'll get 0 in the numerator, we'll get 0 in the denominator. So what we do here? We'll factorize the denominator. Now x and x will be cancelled. So we get 2 over x plus 1. We substitute 0 for x. We get the final answer 2. Look at this one. 2h plus 3 whole square minus 9 over h. And h approaches 0. No way. So we expand the bracket. We factorize. We simplify and factorize. Again, h is common in the numerator. We take h outside the bracket. The factors are h times 4h plus 12. Now h and h will be cancelled. So we get 4h plus 12, substituting 0 for h, and we get 12. So that is the end of part 1. Hope you understood the concept of limit. Keep on watching the videos. Wait for more videos on calculus. Learn and score in the exam. Thank you.